Exercise 10.4 states, at a Midwestern hospital there are a total of 932 births in 20 consecutive weeks. Of these births, 216 occurred on weekends. Do the data reveal more than chance deviation from random timing of births? Test for goodness of fit with two categories of births, weekday and weekend. Use a non-directional alternative and let alpha equal 0.05. Okay, so we had a total of 932 births. Okay, and we have two categories. We have those born on the weekend and those born on the weekday. Okay, a total of 932. And 216 were on the weekend, meaning that 932 minus 216, the remaining 716 were born on weekdays. Okay, so here, if births were completely random, there's 2 weekends days, so 2 out of the 7 days are weekends, and 5 out of the other 5 are weekdays. So this is what we observed. So our expected numbers, the expected numbers would be 932 times 2/7. That's how many we would expect to see on weekends if babies born were random and had nothing to do with whether it was a weekday or weekend. And the other, we would expect 932 times 5/7 to be born on weekdays. So that number, so we're expecting 266.3 to be born on the weekend. And we see 600, and we would expect 665.7 to be born on the weekday. Okay, so our chi-squared statistic, again, is observed minus expected squared divided by expected. So here we have 216 minus 266.3 squared divided by 266.3 plus. Okay, so that's how we calculate our chi-squared statistic. And here, let's see what we get. 216. Get 9.501. And so our total, my chi-squared statistic is 13.3, and I have 1 degree of freedom. Okay, 2 categories, 1 degree of freedom. So we go to our upper tail probability, or our chi-squared table, and we see that 13.3 with 1 degree of freedom puts us between values 10.83 and 15.14. We're in between here, and this has tail probability of 0.001 and 0.0001. Okay, and so once again, our null and our alternative hypotheses, these were non-directional. So here we're saying the probability of being born on the weekend is equal to 2/7 versus the alternative, the probability of being born on the weekend is not equal to 2/7. Here our chi-squared statistic is 13.3, which is pretty extreme, meaning the tail probabilities are is going to be between 0.001 and 0.0001. So our p-value is very small. And so we reject the null hypothesis, and we say that the probability of being born on the weekend is not equal to 2/7. And apparently it seems that the probability of being born on the weekend is smaller than 2/7 for whatever reason.